The following sequence shows the laying of a 400 mm diameter sewer in a residential area using a Bortec BM400 with double-walled pilot rods and groundwater auger. The sewer is to be installed 4 meters below ground level and below the groundwater table from a working shaft of 2 meters diameter. Traffic is unaffected, and the new line can easily pass beneath existing services. Damage to the roots of trees and bushes is avoided by the use of this method. Work on site commences with the construction of the launch and reception shafts by the caisson sinking method. The precast concrete sections are sunk into the ground as the soil inside is removed by the excavator. To avoid ground loss, the water level inside the shaft must always be higher than the water table in the surrounding ground. When the shaft has been sunk to the required depth, the concrete base is placed underwater. The compact site setup consists of the boring container, the hydraulic power pack, and racks for the pilot tubes and auger casings. After positioning the boring container above the launch shaft, the crane is extended so that the BM400 machine and base frame can be lifted out of the container by the 2.5-ton hoist. The cover boards are removed from the floor opening and used to form the guardrail around the top of the working shaft. The base frame is first lowered into the shaft and easily set for height, grade and line before being braced in position. The BM400 is then placed on the base frame and fixed in position. Use of the base frame simplifies the operation and eliminates the difficult time-consuming job of aligning the boring machine. After the machine is set up, the guidance system is installed. The theodolite with its electronic camera is mounted on a height adjustable support, independent of the machine. The theodolite is set to the required height, grade and direction. A monitor screen fixed onto the wall of the shaft allows the operator to view the target through the theodolite-mounted camera during the piloting operation. The first step is to install the pilot rods. The double-walled pilots consist of a pilot head with an integral LED target, an outer screwed casing and an inner pilot rod. As the pilot is advanced, the camera on the theodolite can view the LED target on the pilot head through the hollow pilot rods, and the crosshairs on the monitor screen indicate the correct alignment. By rotating the inner pilot rods, the operator can turn the pilot head to use the inclined plane at the front to correct any deviation from the intended line or level. The pilot head is pushed out of the launch shaft through a flexible seal and into the soil. Pilot rods are added and jacked into the ground. The pilot rods are jacked into the ground without rotation, but if any deviation from the intended alignment is visible on the monitor, the jacking is stopped and the pilot head is rotated to correct the deviation when the jacking procedure continues. The inclined plane on the pilot head creates a reactional force from the surrounding soil to achieve the steering correction. When the pilot head arrives on target at the reception through the seal, the pilot rods with the pilot head are disconnected and lifted out of the shaft. The pilot rods are then followed by a reamer coupled to steel casings with augers inside. The ground is excavated by a special cutting head on the reamer and transported by the augers back to the muck skip in the working shaft. The reamer with the groundwater auger is connected via steel arms with the pilot rods. The special cutting head works behind the steel arms. In the case shown, the reamer is designed as a groundwater auger. In the first steel casing there are two bulkheads, each with openings in the lower area. The auger in this casing also has two bulkheads, with their openings 180 degrees apart. Thus only one pair of openings through the bulkhead walls is open for the transport of excavated material at any time during rotation of the auger. When the back bulkhead is opened, the front bulkhead is closed. When the back opening starts to close, the front one starts to open, and vice versa. The excavated material that is conveyed out by the augers falls into the muck skip in the working shaft. After the completion of each boring stroke, the muck skip is lifted out of the shaft and emptied before the next casing and auger put in place. When the reamer reaches the reception shaft, it is disconnected and lifted out. If product pipes to be installed have the same outer diameter as the casings, then the first product pipe is coupled to the casings in the launch shaft and jacked into place in the third step of the operation, like the clay pipes in this example. During this operation, the jacking force only has to overcome the skin friction. As the product pipes are jacked into place, the augers and casing are disconnected and lifted out. When the last casing reaches the reception shaft, the jacking procedure is completed. After an inspection, the sewer can be commissioned. If a sewer with a bigger outer diameter is to be installed, a second reamer enlargement is used for the third step. In the launch shaft, a reamer with a direct drive unit is coupled to the last casing. The product pipes are pushed in directly behind the reamer. The drive unit in the reamer is powered through hydraulic lines that are laid through the following product pipes. The ground is excavated with a special cutting head and transported through the steel casing to the reception shaft by the anti-clockwise rotation of the augers. The excavated spoil is removed from the reception shaft. When the reamer reaches the reception shaft, the sewer is complete. The process technology shown in this presentation makes it economically possible to achieve the benefits of trenchless technology, where previously open-cut trenching methods with all the disruption and disadvantages would have been used.